Excited today to bring this great case study of success to you. I'm going to turn it over to my good friend, Dr. Serene Elmoman. She is somebody that I've known for a few years, and she does incredible work. And so, Serene, I'm going to turn it over to you to introduce your panel and your panelists.
Awesome. Thanks, Jill. So nice to be here. Thanks for having us. I'm excited to share some hopefully insightful information around the topic of how can we build resilient schools and leveraging data to create safe, sustainable places for our kids and teachers. And we have a great list of things we're going to go over today that hopefully will give you some good insights into the topic and some good takeaways to take back with you and hopefully make big changes and impact in your schools and with your partners. What I'm excited about is that we're going to be showcasing two live here with people representing from a couple of school districts, one San Fran Valley School District in Colorado and Montgomery County Public Schools in Maryland. But we'll showcase other school districts as well. I'll be the spokesperson for those. But we want you to leave this with some real life success stories that you can share with everyone. So just for a quick introduction, as Jill mentioned, my name is Serene Almomen. I'm the CEO and one of the founders of a company called Attune, and we are based out of just outside of DC in the Northern Virginia area. And I'll hand it over to Curtis to quickly introduce himself.
Thanks, Serene. Hi, everyone. My name is Curtis Leonard, and I'm the Energy and Sustainability Specialist at St. Vrain Valley School District in Colorado. We're based in Longmont, Colorado, which is north of Denver and south of Fort Collins. And I'll pass it to Richard.
Thank you, Leonard. My name is Richard Benjamin, and I'm the program manager in the Division of Sustainability and Compliance, responsible for sustainability programs, energy conservation, and recycling and utilities.
Very good. And with that, we can go ahead and get started. So just a quick background on what we do at Attune. We're very much in the school of thought that we can use and leverage technology to modernize school buildings in a very easy and non-intrusive way. And that's what we bring to the table. We have sensors, different types of sensors that go to in school buildings to get real-time data so that we can quickly identify what needs to be done and how we go about doing different modernization projects without doing a lot of heavy lifting or revamp, doing big revamps that are not necessary. So starting with data is kind of the way we look at the world. And we have been fortunate to work with schools across the nation, east to west. And why that's important, and hopefully we'll bring that to you today, is that we've learned so much in terms of, school buildings, what they need, what type of sensitive data is important. It's how it's different from different geographies, ages of school buildings, and whatnot. All those are factors in creating a very solid program that leverages data to make improvements in school buildings. And so when we talk, our topic today is about creating resilient, sustainable, and healthy buildings, school buildings. The first thing that I always like to talk about is why do we even talk about school buildings when we talk about sustainability and resilient infrastructure, where, well, at a general level, we know that in terms of carbon emission, buildings represent 40% of the carbon emission in the world as an asset class. And so if we want to move the needle in terms of reducing carbon emission, creating a more sustainable infrastructure, we have to look at buildings. And then if you look at all types of buildings, school buildings specifically are low-hanging fruit because a lot of school buildings are aging infrastructure. So that means that there is a lot of waste that from energy side of things and maintenance side of things of buildings and whatnot that is represented by that group. And we have 100,000 school buildings out there in the US specifically. So it's really, if we can make school buildings more efficient, we can move the needle better in terms of sustainability and creating resilient and efficient infrastructure. And when you look at school buildings and what systems are actually in fair or poor conditions, 3 of the top 5 represent plumbing. So, all things related to water from that side of things and sustainability, heating, air conditioning, anything related that treats the air, filters, and ventilates the air. And then all the energy management system, lighting and whatnot. And why it's important to know this is that the good news is that those types of systems there are now sensors and technology that can plug in to that infrastructure to give you visibility on how they are performing really easily and non-intrusively so that you can start to put together a plan to improve the infrastructure. And why do we want school buildings to be other than the macro level of reducing carbon emission and things like that? Well, there are additional benefits that are specific to schools if we can make school buildings more resilient and healthy. And those include cost savings, the real cost savings to having a better and climate resilient school buildings, risk reduction, increasing attendance, which actually ties, a lot of schools are funded based on attendance. So there's that benefit, double benefit, and then community support and goodwill. And we'll start with the last point. One of the things, so just to share some statistics with you from community awareness of the need for healthy and sustainable school buildings, is that we now know that students in green certified schools score 5 to 14% higher on standardized tests compared to students in non-certified schools. So it's almost double, in some cases double digit improvement in educational attainment. And then also, if we look at air quality, specifically indoor environmental quality, schools that have proper lighting and better ventilation are linked to an increase in student performance by up to 15%. So there are reasons, really good and important and strong evidence that it matters to the students that we have better school environments. And at the end of the day, that's the mission of schools, right? Is to educate, provide the best education and educational environment for the students and staff. The other aspect related to communities that the stakeholders are changing. Parents and teachers are becoming increasingly informed about sustainability and healthy school buildings practices. And that evolving mindset is reflected in the growing demand that we're seeing for sustainable and healthy school buildings, to the point that some parents are sending air quality monitors in their kids' backpack. And then we read often some of those strikes from teachers and whatnot that talk about indoor air quality and whatnot. And I'm a mom, I have a kid in elementary school, and last year's math teacher was sending us reports about air quality, ozone levels, outdoor air, and whatnot, so that we can prepare the kids before we send them to the school. And that just represents how the mindset is evolving, and we just have to address that and have to take that into consideration in looking at what we need to now change in our school buildings and the school environment. Shifting to cost reasons to create better school buildings. Repairs and maintenance expenses are over 30% more costly than since COVID. So in just the last 5 years, they've increased by 30%. So now if, let's say, an HVAC system part fails, it's not a simple change that the school building can do. It's 30% more expensive for them to make that change and maintain that system, both in parts and labor. And we all know that school budgets are tight, and so it's a meaningful issue to take into consideration. And if we can extend the life cycle and prevent these types of issues from happening, then we can save money. The other factor and why we're talking about this topic is that some environmental changes that we're experiencing. Wildfires are increasing in frequency and intensity, which is causing a range of physical and mental health impacts for students. And that goes back to attendance issues and, how can we prevent those types of things. Another impact of these natural hazards is that they have disrupted education for over 11 million children from 2000 to 2019. And again, that's ties to attendance, and attendance ties to how schools are funded. So mitigating these issues may tie directly to very important factors in keeping schools, up and running. And the good thing, and one of the strong statistics we're seeing is that every dollar spent on disaster mitigation in the U.S. saves $6 in future disaster costs. So there is an ROI. If we take care of these issues and do something about them, we can bear the benefits later. And another thing to think about is the fact that we are experiencing more and more back to school cooling demand. It's getting warmer out there, and to the point where about 36% of students attend schools in areas that qualify as heat islands. That has bring with it a lot of heat-related health issues. And I put here in the slides a couple of screenshots from Climate Central that shows back to school cooling demand, annual cooling degree days, and how it's been changing. So basically this is, and I took Denver and Baltimore because they're the closest in terms of available data to the two speakers we have today. And you could see that the annual cooling degree days basically is the days where the daily average degree is above 65%. So what we're seeing here is that the number of days that have between July and September, so when we come back from school, they're above 65, are increasing 61% in the Denver area since 1970, and 19% the Baltimore, Maryland area. And so why this is important to know is because without adequate air conditioning, a 1 degree Fahrenheit hotter school year reduces that year's learning by 1%. So you can expect that the learning impact is following the same trend line, but on the negative side of things. So this is back to attendance and why this is important to think about. And then extreme heat not only impacts respiratory issues and cardiovascular health outcomes, but they also make kids less physically active. So there's multiple ramifications of this particular issue. And the last thing I'll mention is that the energy costs has increased in the US in just the last 5 years, since 2020. Electricity costs increased by 29%. And pipe gas costs increased by 35%. So again, if there is waste, and just to, in case you don't know, HVAC systems that tie to energy and air quality, they are typically the cost of the consumption from HVAC system represents 70% of your bill, the energy bill, the school's energy bill. So if that's getting more expensive, it's really important to maintain that these systems for health reasons, but also from a cost reasons. And yeah, so there's just so many reasons to think about, what can we do with this aging infrastructure, and how can we leverage technology? Well, one of the things I always say is that you cannot manage what you don't measure. Now we know that we need to do something different with school buildings. There are many reasons why we want to enhance how resilient the building is and how healthy it is. And the good news is, again, there's technology and advancement in sensor technology specifically that allows us to get that data that we could use then to better manage school infrastructure. So the three buckets of data that are now readily available, they're cost effective, they're easy to install, are indoor air quality, outdoor air quality, and then energy data, including electric power, gas, and water. On the air quality data, the particular sensors that are typically used and can provide insight into how good the ventilation filtration system is doing is temperature, humidity sensor, CO2, and particulate matter sensor, and volatile organic compounds. So these are kind of the basic sensors. But in areas where there's high pollution, for example, and more wildfires and whatnot, sometimes NO2, CO, and ozone would be strategically important and can be deployed. Again, these sensors are available. There are, good highly rated sensors that give you good data. UL 2905 is one certification to use to determine the accuracy, quality of sensors. And it is the certification that ASHRAE is requiring for if you're installing air quality sensors in educational facilities. And depending on the budget for schools, you can go down to 10% of classrooms. So if you have school buildings, it's 40 classrooms, you can install 4 indoor air quality, and you up to 100, so every classroom. And anything in between. But if you get at least 10% coverage, you have statistically significant data set to make good decisions from the data and drive some insights that can help you manage the building better. And outdoor air quality sensors are also becoming available, similar sensors as the indoor air quality. Sometimes it could be actually, if you want to get outdoor air quality data, you can simply plug in the indoor air quality sensor next to outside air intake inside the building, but also this technology that is weather rated or outdoor rated, and those could be outside the building. So there are different configurations to do that. And then on the energy side, submetering water, gas, and electric is available. You can also get pulse data from the meter itself, which is another very easy way to start to look at the consumption and identify any significant deviations and issues and spikes on that side of things. And we're getting ready to talk about specific use cases from the two school districts we have here today. But I wanted to show this framework that this is one of our good partner, Managing Director of Sustainability, Tom Stanchek, at Stonewig, which is a commercial real estate owner. And the reason I share his framework for how to, his climate action and real estate kind of playbook is that commercial real estate have advanced in the area of resilient and healthy buildings faster, I guess, from school buildings. So we don't have to start from scratch. We can leverage what, other industries have done. And this is an example of what commercial real estate is, how they look at the world when we look at climate, when we think about climate action. The first step in making a difference and moving the needles to collect building data, then you know which partners to work with, you implement the right strategy, you achieve certification, enhance the tenant experience in the space, and then deliver return on investment. So something like this we can expect that, once we adapt some of this technology and framework, we can see similar results. And with that, I will turn it over. We'll start to talk about success stories. I'll turn it over to Curtis to talk about how they do it at their school district.
Awesome. Thanks, Serene. First off, I just wanted to flag I'm feeling a little under the weather, so please show me some grace if I start coughing at some point throughout this presentation. Serene, that introduction was excellent. I also want to mention that St. Vrain Valley Schools is at the beginning of their journey of collecting data and using that to make data-informed decisions. So if you saw all of that and were intimidated of where do you start, St. Vrain Valley Schools is the example of where you can start. So like I said earlier, we're a school district north of Denver, south of Fort Collins, located on something called the Front Range, which means that across the 411 square miles of our school district, we have some areas that are very mountainous and in forests, and we also have some areas that are very much like the plains. With over 60 buildings, 8 communities, 32,000 students, and 5,000 employees, our district includes a lot of people and communities and stakeholders when it comes to school districts in Colorado. So we can go to the next slide. So my department is energy, sustainability, environmental health, and safety. And our department is working on long-term sustainability planning for the first time, trying to map out years in advance what our team will be working on. And part of that research, we've been wanting to work with students to answer some critical questions. And one of them was, what do students in St. Vrain Valley Schools have to say about energy and sustainability? So to do that, we asked them. This was one of the more intimidating things in my professional career, where I set up a table at each of our high school cafeterias and just talked to students, asking them to come over and tell me what their priorities were as it relates to sustainability and the environment, energy. Our team came up with a list of around 20 different topics to choose from, and students were encouraged to circle their top 5. From these results, we tabulated what the most frequent chosen themes were, and we can click. And so our top 3 were energy efficiency, waste reduction, and number 1, which honestly was a surprise to me, was indoor air quality. But if you think about it, students today grew up in a world with airborne pandemics, and in my community, wildfires. So it makes sense that they are more acutely aware at the role that the air they breathe plays compared to previous generations, how it can impact their personal and environmental health. So we can go to the next slide. So now that we know that IAQ is something that students care about, it's the single most important sustainability priority for high school students from last school year's survey. We want to better bridge the connection for IAQ between energy and sustainability and environmental health and safety. So in our holistic definition of sustainability that we're trying to craft, IAQ definitely has a seat at the table. 44 of our schools already had attune units. That was because of a unique grant program between CU Boulder, a local university, and the Colorado Department of Public Health and the Environment. So we're using attune sensors in our classrooms to make data-informed decisions. Serene said you can't manage what you don't monitor. And I think air quality is really interesting. I like to describe it to teachers and to my colleagues as something that's almost ethereal. It's very hard to pin down with just our human senses. And when we do talk about it without data, we often refer to air quality as good air quality or bad air quality. And that's so vague, which is why attune units are so important to our school district. It's very value aligned with our district because here in Colorado, wildfires are a key environmental threat. It's something that our teachers unions have spoken quite a bit to my supervisor about, just about how it is an important priority of having healthy air quality in our learning spaces. And like I said, IAQ is going to be growing as a departmental tool because they've proven themselves as a way to provide peace of mind, whether we are working in the midst of a crisis, which we'll get to, like an environmental crisis, or just individual teacher questions or complaints or curiosities. We will be expanding this even further. And part of that was reinforced by what we learned from the Stone Canyon fire in July of 2024. So knowing that we can have accurate real-time air quality data during an event like this has been crucial and has really set the stage for us to prioritize indoor air quality monitoring further. So next. So the Stone Canyon fire was a 1,500-acre fire in the town of Lyons, near the town of Lyons, I apologize, in July 2024. And the closest it got to was around 1.5 miles from Lyons Elementary. So Lyons was one of the 8 communities in our school district. At this time, there were realistically, I believe, 3 fires within a 25-mile radius happening in our community. So in addition to the actual wildfire, there was wildfire smoke coming from a litany of directions. But during a crisis like a wildfire, our emergency response team, which is housed in district operations, is led by our safety and security team with support from planning and transportation. And these teams rely heavily on data and softwares that they use to manage routes, spatially track where students, residents are to ensure that everyone in the evac zones knows about the evacuations and the things that the community is trying to communicate. So it only makes sense that energy, sustainability, environmental health, and safety also uses data and software, attune, in our post-crisis remediation efforts. So we were able to get granular, spatial, classroom level air quality data to understand the conditions in our schools during and after events like the Stone Canyon fire. So we leveraged our attune data to have an informed air quality assessment, seeing how our air quality changed over time, leading up to the fire and after the fire. And this strengthened our district's ability to respond effectively. And we can go to the next slide to show what that actually looked like. So on the left, we have, well, both of these are actually our dashboard, but on the left, we have a blueprint of Lyons Elementary. The 4 blue dots you see represent classrooms that have sensors. And on the right, you can see what the sensors are actually tracking. So with our indoor air quality sensors, we keep track of temperature, humidity, CO2, VOCs, and particulate matter at 2 sizes. And if we go to the next slide, we can see a data over time. So this shows particulate matter in Lyons Elementary over the course of a month. So the blue, the orange, and the black lines represent 3 different classrooms where we are collecting data that you can see over time. This gives us a really granular spatial view of what air quality looks like across classrooms. And this gives us the ability to identify patterns, but we can also zoom in on specific timestamps next to see the exact air quality readings in each classroom. So these real-time snapshots were so helpful when making the case that the crisis remediation is not over once the fire goes out. There's still work to be done. Um, and this was really helpful to show people on our team that something they can't see can still have an impact on occupant health. So, excuse me. So this data is something that we can share directly with our HVAC control specialists. And again, it can help us bridge this gap between energy, sustainability, environmental health and safety, and our facilities and building operations. And it's also helping us think critically about what advisory role our team should play when it comes to supporting safety and security with resilience efforts when we think about future environmental challenges in our district. And I want to flag that I met Dan and Serene from Attune actually at a conference on resilience. So it's very fitting. But we can go to the next slide. So this brings us to the future of indoor air quality in St. Vrain Valley schools. So we're developing a sustainability management plan. We're really excited about it. It's still in the works. But because of the role that indoor air quality played in student passion as something that the district needs to be prioritizing, it's going to be one of our 6 integral facets of sustainable student success. So we're starting a high school internship program. I'll have 3 high school interns in fall 2025. And from talking with the applicants, indoor air quality is something students are really passionate about. So we still haven't selected our interns, but chances are one of those interns will be supporting me with creating an IAQ management plan that will be housed within our sustainability management plan. All of our future schools, we have 5 on the horizon with our most recent bond election because our district is growing. Attune units will be a part of the design specs, so we're guaranteeing that we'll be monitoring indoor air quality in our new builds. And from a recent conversation with Colorado Department of Public Health and the Environment just this week, we were talking about opportunities for partnerships to design an educational library of resources to plan for wildfire smoke management, which is something that we're thinking about a lot here in Colorado, specifically within our schools. So this is just the beginning for our school district. I think the data that we've been able to gather from our Attune units have really helped us get from square one to square two. And we're really excited to see what the future holds as we have more data to support more strategic decision making and more thoughtful management of our classroom spaces. And like I said, we're just at the beginning. There are some school districts that are going above and beyond and have really shown what this can look like to the max in your school district. And I think it just makes sense to pass it on to Richard Benjamin from Montgomery County Public Schools, who will share how his district has maximized the impact of their IAQ data.
Thank you, Curtis, and Serene. My name is Richard Benjamin again, and I'm a program manager in the MCPS Division of Sustainability and Compliance. So we have 2 components to our division, the sustainability part of it and the compliance part of it. So on the compliance side, we have the indoor air quality, pest management, mold remediation, and all of those good things that happen over there. And on the sustainability side, we are responsible for the utility bills in MCPS, waste reduction, energy conservation, and the behavioral side where we go out to schools and meet with students and staff and to promote sustainability and all of the green behaviors in school. So exciting work that we do. And so a little bit about Montgomery County Public Schools. We have 212 schools. We are the largest school district in Maryland. We have nearly 160,000 students, and our staff, we have about 26,000 staff members this school year. So, and we are just outside of Washington, D.C. We're one of the largest school districts in the country as well. In 2022, MCPS adopted the sustainability policy, which sets a goal to reduce 80% of the greenhouse gas emissions by 2027 and a 100% reduction by 2035. This goal, this sustainability policy was developed after Montgomery County itself adopted a climate action plan that has the same greenhouse gas emission reduction targets. So we installed nearly 10,000 IAQ sensors in our school buildings throughout the district. And these sensors are in all of our learning spaces in the classrooms. The when this was installed, the staff, our colleagues in the IAQ side were very excited about the kind of information that they can gather from these sensors. And I was looking at it from the operational side and the efficiency of our school buildings and how we can operate our school buildings more efficiently, because every dollar that we save on the operation of our school buildings can go back towards educating our students. And, as we have, Serena has already mentioned about the budgets and how important the budgets are, and how we don't have enough budget to fund everything that we need to fund in our school systems. And so these IAQ sensors provide primarily on the IAQ side, but also I'm using this to see how we can improve the energy efficiency in our buildings and ultimately result in cost avoidance in the utility bills that we pay for our school system. With 212 schools, our utility bills for all of the utilities is around $50 million a year. And so every little that we can save, whatever percentage that we can save on the energy used with whatever means that we have, will go towards reducing the operational costs of our buildings. And Serene mentioned earlier about the different energy monitoring equipment that can be placed in schools, right? The real-time monitoring that you can have on electric use and the water use and natural gas use. Unfortunately, we do not have real-time monitoring. And so we are using some of the information that we have to assist us in monitoring our temperatures in space temperatures. A little bit again about MCPS. We've been the recipient of the U.S. Department of Education Green Ribbon Award, and 113 of our schools are Maryland Green School certified, which is about 53%. We just received 12 schools that received the certification this just last month during Earth Day. So can we go to the next slide, please? So this is an example of how the data is available to us. This example that you see here is during the cooling season. We received an email from a teacher at a particular school saying that his classroom was hot. And when we looked at the IAQ data, the median temperature that's available to us, we found that 14 of the 18 classrooms in that wing were out of the specifications that we have. So we have 70 degrees for heating set point and 76 degrees for the cooling, cooling set point. We'll see that in the next slide. But this is an example of where the 14 of the classrooms were beyond the set point that we would like the schools to be. And some of you may be from the building operational side on the webinar today, and you know how tricky or how technical expert you need to be to get into the building automation systems to look at the performance of the buildings, the school buildings, right? At the present time, we have 3 different building automation systems. reliable, structural and HI solutions. And each one of those is very different how you get into to drill down to the classroom level to see what the temperature in those classrooms are. But this gives us a very easy view for non-technical staff to come to one place and you can see how each of the classroom is performing. And all of this is gathered from the median temperature readings and the median readings that is gathered from the IAQ sensors. So this helps to remotely prioritize how we're going to handle a situation. So, for example, in this case where it was not isolated to one classroom, looks like it's a whole wing. So it is easier for us to alert our maintenance staff to look into what is happening in this school. By all means, this does not replace the building automation system. Obviously, building automation system is a lot more complicated and provides a lot more information for the technicians to diagnose and to figure out what is going on. But this gives a very high level view of what is happening so that the technicians or our staff can prioritize what we need to do. Next slide, please. So this again is a report that we receive, and as I mentioned earlier, that the temperature set points that we like to maintain is 70 degrees for heating and 76 degrees for cooling, plus minus 2 degrees. So both examples that you see here were taken during the winter season, so during the heating season. So on the left, you see example of schools that are beyond the heating set point that we would like to maintain. So in the highest is at 77, and so and it is sorted according to the highest to the lowest temperature. So we know which schools are the median temperatures beyond the set point. And on the right-hand side, you see again sorted from the lowest to the highest, and there are three schools over there that are cold. So all of this gives us a very high level view of what is happening in our schools, and non-technical staff can really look at this and say, hey, maybe we have a problem here, and let's dispatch or alert our maintenance staff to take a closer look at this. Next slide, please. So this is another good tool that will really become helpful as we get into the summer break. During the summer break, most of our schools are not occupied. I mean, we do have some summer classes and some use in the buildings, but majority of our buildings are not occupied. And during the summer months, there's great potential for high humidity, and as a result of that, concerns of mold in the schools. This tool right here gives us allows us to see what is happening in the spaces when the building staff is not available to walk around. I mean, obviously the building staff is in the building and they, may not be able to walk into every classroom every single day, but this information right here gives us a portfolio view of the humidity readings of each of the classrooms. And this example again was taken during the winter season. So one of the classroom, your classroom 2, you see, it indicates that the humidity level was dry. So in the same thing, if in the summer season, if the humidity is high, it will give us the same alert as well. And again, we can remotely view what is happening in the classrooms and alert the on-site building staff to take a look and see what is happening over there and take corrective actions, and so that the last thing we need is when we're coming back in the fall and teachers are coming back in and we have an issue in a classroom. And I'm sure we have examples of those, and we don't want to deal with that scenarios. Next slide, please. Oh, yeah, so that's the presentation that I have, and I'm going to turn it over to Serene again to continue.
Serene, do you mind if we ask a few questions that we have
Yeah,
for
please go ahead.
yeah. So Tracy Woods has a question for Curtis. She asks, what brand of IAQ monitor is that you're using?
Um, we're using the Attune units.
Okay.
The units that were on, I don't know if Serena, if you could go back to the slide to show your product, but
Yeah, I think, let's see, this one.
so yes, as Serena just highlighted with the mouse, we're using those sensors. And we are in conversation about the pairing some outdoor air quality sensors. But that's a conversation for another day. Um,
Perfect. And there's another question for you, Curtis. This comes from Matthew. He says, given students rated IAQ as their highest priority, were you able to share your data back with them and the community? And also a comment, the intern program sounds incredible.
Thank you, Matthew. Yeah, so to answer that question, we had some students attend a feedback session with district leadership on April 1st to kick off Earth Month. I forgot that it was also April Fool's Day, but the focus was Earth Month. And some of those students were there to see that us go over kind of like the top priorities. And in addition to that, in my role, I've tried to curate relationships with our high school environmental club teacher sponsors. So I almost have like a little mailing list where I'm keeping folks abreast on what's happening in the world of um, sustainability in St. Vrain Valley schools.
Awesome. And then we have one last question, and then I'll go back to you, Serene, and people can ask questions towards the end. This one's from a brilliant individual whose last name is the same as mine. It's my daughter, Catherine. No, I'm really excited to have her on. She says, what effect do cleaning chemicals have on indoor air quality? And do you have data that shows any difference in the specific cleaning chemicals on air quality?
Typically cleaning chemicals, you could see in terms of sensors, you can see them show up in the volatile organic compound sensor reading. A lot of the air quality sensors that have a volatile organic compound, it's a total volatile organic compounds. It's not necessarily identifying the specific compound that is being emitted by cleaning products. But you can go to a granular level and add sensors like formaldehyde, because not all volatile organic compounds are bad. Um, as an example, you could see an elevated reading of VOC if you open a bottle of wine. So, which, in this case, we don't worry about it, but in some cases, like, maybe harmful cleaning products, we do care about that. So we want to, pay attention either way. But yeah, if you're specifically worried about a specific type of chemical, you can add more specialty sensors to make sure that you keep an eye on that, and flag and alert when, these levels are elevated. And that's how we kind of, if we want to manage that particular issue, we would do that.
Thanks, Serene. And to all of our participants, keep your questions coming. We'll have another QA session at the end, but I'll turn it back over to you, Serene.
Yeah, so I am gonna do a rapid fire. I was just wanted to add more case study success stories of using data to help create better resilient and healthy school buildings. This is from Prince William County Public Schools in Virginia. They're the second largest school district in Virginia. And this use case is related to using energy to make more resilient school building, reduce carbon emission and greenhouse gas reduction, especially during high demand events. So when the utilities say that there is a big stress on the grid, they participate in, because the school buildings using a lot of energy, they can participate in reducing the energy consumption during that period so that they can, the grid doesn't fail. So this is an example of how they do that. They install sub-meters in the buildings. Every building in the district has this type of solution. And then they have a dashboard that's most of the time is red because we're consuming and the buildings are running and not a special event. But if, they get a call from utilities and say, hey, we need to curtail energy consumption, you want to come to this dashboard and see everything is green because you're changing set points and configuration building systems to get to that better level, more conservative level. So it's a quick way to see if the strategy is working and that things are operating where they want. So that's one use case. Another use case, this is where when we talk about air quality, people think CO2, particulate matter, VOC, at least more advanced sensors, and how it use that to better improve air quality, which is great. But like Richard was mentioning that simple temperature and humidity data can also be really helpful to just look at and at a portfolio and a portfolio level as a school district. So this is in the Denver Public Schools in Colorado, where they use the IQ temperature data specifically to pinpoint the schools that are above 85 degrees. As you can see on the right side, the bar chart, which classrooms in middle schools that are in that condition, so that because it's not comfortable, and because the issue that a lot of schools are facing is that typically these high temperature, we used to see them in summer break when it's the buildings are unoccupied, but now we're seeing them shift into the school year. So not a lot of buildings are set up to handle high degree when it's occupied. So using the sensor temperature data can help address that issue, mitigate it, and create a more comfortable environment. This is another Denver Public School use case where they use the data to identify the classrooms and the schools where the air changes per hour using CO2 sensor is above 5, or they're lower than 5 air changes per hour, and 5 air changes per hour is the CDC recommendation. So we want to change in an hour, one change air 5 times, basically. So this is a quick way. Using the data, you can sort out and identify the schools that don't meet that guideline. And the good news here that you see in the data is that not every school is problematic and not every classroom, but there are some problematic ones. And these are the ones they use to use for targeted HVAC upgrades and adding HEPA filters. So their dollar can be stretched more to address the right issue at the right time. This is an example of Clark County School District in Nevada, near the Las Vegas area. And they have air quality monitors in their portables, which are notorious for bad air quality. And what they've noticed in that instance, that the temperature reading was always the same, which meant that the thermostat wasn't turning on and off, and they changed it to a smart thermostat based on that insight. And now you see the up and down, which means it's on and off, and that especially at night and then in the weekends, which save them about 50% of energy. So it's not just better air quality, it's also energy saving. This is an example where the school found at the early times of the day when the HVAC system goes to occupied mode, so it turns back on. They saw a PM burst, which meant that the ducts need cleaning. They have particulate matter that is being sprayed into the space when the HVAC system comes online. So they had a work order to clean the ducts, which now you see the data. You don't see those bursts. And the benefit of that, not just improving building hygiene, but you're saving energy up to 60% if the ducts are cleaner and you bring more airflow compared to unclean conditions. This is another example where the humidity data was used to flag, abnormal behavior. And as a result, a work order was issued, and they looked and found that there was a roof leak. They got resolved the next day, and you can see the data goes down. So there's a lot of operational value. Couple of example where this is school district and an office building within the same block, comparing indoor air quality and outdoor air quality during the Northeast wildfire a couple of years ago. The blue line represents the outdoor particulate matter level, and the black line represents the indoor particulate matter level. And you can see that the office building, you can barely see a black line, but the school building, the indoor particulate is almost tracking with the outside. So that was insightful, and even comparing the two buildings, because we could tell them, hey, this is what the office building is doing. And if you do make these changes, you're going to have the same results. So that was the use case. This is similar. This is all the way to the West Coast in Bellingham School District for wildfire preparedness. They have indoor and outdoor air quality, and they have AQI, air quality index, created, and you can see that for outdoors compared to indoors. The blue line is outdoors, black is indoors, and you can quickly talk to the community and share this data and say, yes, we know wildfires, outdoor is bad, but look at indoors. And that creates a lot of goodwill and comfort. Mold is another one. This is, we talked about it, Richard talked about it, using humidity data, but also using machine learning and AI to predict molds before they become visible. So now that you can kind of analyze the data to do that. Big headache for schools is vaping. You can use particulate matter sensor and volatile organic compound. And there are algorithms where you use the 2 data points to detect vaping and to detect if the kids are masking with deodorant or perfume and whatnot, and distinguish the two and provide the right alert at the right time. And advancement in AI. I mean, a lot of people say, Serene, you love the data. Can this be a lot of data? Well, with analytics and AI, there's a lot of value in having that data, because then you can ask really important questions like where the classrooms that have most bad air, or percentage of time we're above a certain threshold and things like that, and can see the data. And this, in the beginning, I mentioned the framework from commercial real estate, but there are actually some schools like Denver Public Schools that also created their climate action plan. And you see here that one of the main items in that plan is creating a smart building, because the awareness that data can drive a lot of the other results. And with that, we're a minute away. Happy to answer any further questions.
At this point, we don't have any further questions at the moment, but I am going to share my screen really quickly, because we have an opportunity for folks who are going for the NSBA, National School Boards Association Magna Award, to earn some points for being at this presentation. So let me put this up. If you would like to scan this QR code and take a quick survey, and believe me, these are not hard, you can do that, and you'll receive a PDF of a certificate showing you completed this webinar. And if you are going to be applying for the National School Boards Association Magna Awards, which opens up May 15th, you'll be able to upload that PDF to the application. So go ahead and give that a whirl. I want to thank Serene and Curtis and Richard so much for being with us. I think we're going to have to do a part 2 of this because there's so much more to talk about. But this was an excellent presentation. And one of the things that's so important as we embark upon this journey to improve indoor air quality across US schools is to have case studies of success. We have other districts that we can look to who have learned a lot of lessons, and we can replicate their lessons learned. So I want to thank you all so much for being with us.